Okay, this video is the proof of the power rule. So this will help you with the, what is this, T24, the notes for 24. So let's just say if I started off with the function f of x equals x squared. Okay? And I want to find the derivative. So that means that I'm finding f prime of x. I want to see what is that equal to. Well, you know, that's where I use my difference quotient. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. That's my rule that I use, right? So we say we always start off, we first find f of x plus h. So this is my f of x. So in the spot of x, we're going to replace it with x plus h. So I have f of x plus h, which is, that's my x, so that's x plus h squared. Now from the rule we said when we squaring a binomial, I square the first term. So that's going to be the x squared. Then I square the last term. So that's a positive h squared. And then the middle term will be the two multiplied to each other and doubled. So that'll be a 2xh. So that's all f of x plus h when f of x is x squared, right? So then I go and I plug it into my difference formula. Limit as h approaches 0 of x squared plus 2xh plus h squared. So that's all f of x plus h. Then I'm supposed to come and subtract whatever f of x was. That was x squared. So minus x squared all over h. So what happens? X squared minus that x squared, it cancels. So I'm left with, notice I'm still writing limit. The limit as h approaches 0. We keep writing it until we plug in. So I'm left with at the top 2xh plus h squared all over h. All right? So then I notice that each one of those terms have an h in it. So we can factor out an h at the top. I'm left with the limit as h approaches 0 of h will be pulled out. 2x is left in the first term, plus h is left in that last term, all over h. So what happens, I have h that's being multiplied at the top, and the h that's down there at the bottom by itself, so it cancels. So I'm left with the limit as h approaches 0 of 2x plus h. Now I can let the h go to 0, and if I do, I'll get 2x. So looking at what I got, when f of x was equal to x squared, f prime of x was equal to 2x. So now let's look at what visually happened. If I don't look at any mathematics and just look at what visually happened, it looks like they took the 2 from my x squared, my original function. They brought this 2 down into the front of this x. And what did they do to the exponent? Well, remember we said that the exponent of your derivative is always 1 less than the exponent of your function. Remember? So in essence, we really did this exponent minus 1. So really that's 2 minus 1, because I know when x is written by itself, it's understood to be to the first power. So it looks like they took the whatever the exponent was and brought it down to the front of the x to be multiplied. Then they subtracted 1 from the exponent. So if I have f of x is equal to x to the 3rd power, then what you think the derivative would be? Well, if I follow the rule, f prime of x, if I follow what we said we did here, I'm going to bring the 3 down in front of the x. So it's going to be 3x. And instead of having 3, I'm going to subtract 1 from the exponent. It's going to be 3 minus 1, so that's going to be 2, so it's going to be 3x squared. And of course, if I do the power, if I do the, this rule here, the limit definition, I should come out with this if I started off with x to the 3rd power. So what's the general formula then? Well, general formula meaning what if I have just some exponent? So x to the n power. If f of x is equal to x to the n power, then what will f prime of x be equal to? Well, what I'm supposed to do, I'm supposed to take the exponent and bring it to the front to be multiplied. So that's n times x. And what I'm supposed to do with the exponent, I'm supposed to subtract 1 from it. So this right here is the general rule for taking a derivative of x's that have some power. So we call this the power rule. Okay? So when x is to some power n, if that's f of x, and f prime of x is equal to n, that's the power, times x raised to the n minus 1. And that's the power rule.